What's up? Brandon here from Thirst Mark Podcast, thirstgym.com. We are doing our first YouTube live video here, and this is designed for Q&As, training talk, really honestly, anything that you want to have that's strength conditioning, performance related. We're here to try to help answer some of your questions and just have good quality discussions. So this is the first one. This is something that I wanted to add from the podcast series to where if you didn't listen to the initial episode 25, talked about having guests on, doing some solos, and then having the YouTube live option, which will also be streamed to your normal podcast data wherever you like to consume it, whether that be Spotify, iTunes, whatever. It should all be there. So this is again designed to be some kind of educational based piece. And the real big thing here is, again, to give you the opportunity to ask questions, but also create good dialogue. And I think that's where we try to grow as a profession, is just to talk about different training methodologies and what we do. Now, I will be the first to tell you, there's nobody here for this live stream because, again, I've only done one episode of the new relativity series. You can call it a season if you want, of the Thirst More podcast. It's 1:00 on a Sunday. College football just kicked off, but this will always be on the first Sunday of every month. So you can catch me again in October. I'm actually going to look to see what that date is. That date is actually going to be October 1st. So October 1st will be the next live stream. So come on over from YouTube and just come here and chat, ask questions. Love to bring you on. But because I suspect this will be taking something that takes a while, to grow, I'm also going to show up with a presentation-based experience as well, at least for now. So basically considering this like a lecture-based series. If there's nobody here, that way, one, I've got something to discuss. Two, there's information for you to take from it in case if you can't make it. But three, I think it ultimately provides just a good amount of education, and we can talk about different topics and something that I want to talk about. So the first thing, since nobody's here, we're going to kind of talk about dynamic effort method for athletes. So we are going to really here kind of talk about how we're using the dynamic effort method, not only for powerlifters, but I'm really talking about sport athletes more so than anything else. If you happen to be listening to this in the past, so let's say you're listening to the recording, please understand if you go to YouTube, my YouTube channel at B Smitley, you'll be able to actually look at the slides that I have here as well, which may help you if you want to further educate yourself on this. If you're not, for whatever reason, audio wise isn't doing it for you, you want to be a visual piece, you're a visual learner, that's how I am. This is another option for you. And this will live on YouTube. So it'll be around for a long time, so you can always re-reference it if you want. So we're going to talk about the dynamic effort method for athletes. So the first big question here is, what is the dynamic effort method? Okay. I think we get a lot of things confused here. And so I really wanted to make sure that we're all working from the same foundational vocabulary here as we get started. So what I've got written down here is the dynamic effort method of training is defined as lifting a submaximal weight with maximal effort. By training to move a submaximal weight with as much velocity as possible, the lifter or the athlete develops greater force output than they would by lifting a heavier load slowly. This increases overall strength. The dynamic effort method is one of three core training models or methods used in the conjugate system, or some people like to call it the West Side system, just so we're kind of understand what's going on here. Developed at West Side Barbell by Louis Simmons. And those other two, in case you're wondering, are the max effort method and the repetition effort method. So we're only talking about dynamic effort method here today, but understanding for the most part, this is about lifting things fast. Things have to look fast, have to be fast. We're trying to develop the fast qualities of lifting. And I think if you're listening to this or understand what's going on, you understand that, okay, well, I'm working with athletes. That probably makes sense. Not too many sports intentionally move slow to be successful. So that's at least the definition and the vocabulary where we're going to come from today. The next piece here is just the history of the dynamic effort method. Where did it come from? How did it get started? Where can you use this to help you guide what's going on? So again, I'm going to kind of read here from the slides just a little bit, just so we have some idea of what's going on. But I've got the dynamic effort method is outlined by Zatorsky in his book, Science and Practice of Strength Training. It was originally developed by the Soviets to supplement their max effort workouts as a way to continue the athletes' training during the week without taxing them as much as max effort training. So the first thing that it kind of came around from was managing training load. How can we train more without actually training more, if that makes sense? So we're doing more work, but we're not actually stressing the body as much. So we're kind of greasing the groove. How can we see performance enhancements without having to beat our, in this case, lifters and athletes down all the time? Is there a way that we can do this? And that's kind of how Zatorsky and his book and the Soviets determined that they would use that to help their max effort. And then the objective of these workouts, again, is to train the athletes to explode, exerting maximal force into submaximal weight, to train their ability to exert the greatest amount of force possible. So again, this is about creating the most amount of force, which when you talk about athletes, which is what we're talking about here, force is king. You've got to be able to create force to be explosive, be fast, throw, change direction. Managing forces and creating forces and absorbing forces is all sports is. There's obviously skill acquisition involved, but if you're talking about being able to actually perform on the field or on the court or on the pitch, even, this is incredibly important. You got to understand that force is the name of the game when it comes to sports. And then the foundation of the training method is, using Sir Isaac Newton's second law, which states that force exerted on the object is directly proportional to its mass and acceleration, or as we like to usually say, force equals mass times acceleration, or F equals ma. So, again, we're talking about athletes for this, but that force is the key component. Everything has got to drive that number up. So you can do that by, again, looking at this equation. You can write it out, think about it in your head. It's just a very simple one. You got your mass and your acceleration. You've got to either increase your mass, you've got to increase your acceleration, or you've got to do both to see your force increase. If either one of those decreases, the other one either has to increase to make up for it. Otherwise, you'll see a decrease in amount of force, which is the last thing that we want as working with athletes or as being a performance coach. We don't want to see force go down. We want to optimize force. We want force to always go up in terms of our training methods and what we're trying to get from the athletes. Okay, so here again, we're going to talk about the history continued just a little bit more, and I kind of rambled on about this before even getting ahead of myself. But the goal of the dynamic effort method is to use the submaximal weight that sits in the middle of the spectrum. Okay, it's not stupid light, it's not stupid heavy, it's somewhere in the middle. So we don't want that mass, which would be, the weight that we're using, or the weight plus the athlete, however you want to look like it, could just be the athlete, or load so light that we lose overall force. Again, we talked about that with the equation that if your mass goes down, ideally your acceleration is going to have to go up to make up for that, to create more force. But we also don't want to load so heavy that we have to grind or slow our acceleration to move it. And again, this is really important from the athletic perspective because, again, they've got to be able to accelerate usually in what they're doing in sport, whether that be running, whether that be throwing, whether that be swimming, whether that be changing direction. Speed and acceleration is incredibly important in sports, as we've kind of alluded to, being able to create that force, generate that force, pass on that force to a moving object, like in football, hitting somebody. That's all incredibly important. So the good way to look at this is if you're throwing different objects, okay? We'll just talk about like you're throwing a baseball, okay? That kind of throwing motion. So let's just say the perfect world, our dynamic effort work. Our perfect world is a baseball or a softball, something that's got some load to it. It's not light. It's light in terms of, lifting weights and stuff, but in terms of throwing, it doesn't feel stupid light, but it's also not stupid heavy. It's got just enough weight that we can throw as hard as we want to. And it generally is not going to be affected by the weight. So what I mean by that is, let's go the heavy spectrum first. Let's say I tried to throw, let's just say a shot put. Shot put's a good example. You never would want to do that, right? You think about, that layback position, trying to put, 2 to 3 kilos back there and try to throw it. Well, one, you automatically know right now that you're not going to throw it as far as you throw the baseball, right? Okay. So therefore the mass went up, and the way that it's going to accelerate, that's going to go down. And then we would need to calculate those numbers, but hypothetically, let's say it's all the force is all the same. But probably you're not going to get your force as high because the mass is so big. Your acceleration numbers have to go down so far that you're probably not going to be able to create as much force. Something's going to give. All right. And then the other example would be like throwing a ping pong ball or even a wiffle ball for that matter. When you go to throw it, again, the mass is super, super light, very, very small, and you can move your arm really fast. You've got a high amount of acceleration to move that weight, or in this case, that ball, but it's not going to go anywhere because it's too light. So therefore, the force output's not going to get to where the baseball was. You would think that hypothetically, I know you can make the argument the way the balls are designed, but just go with my analogy here. But you would think you would be able to throw that ping pong ball forever, especially if you're talking about pro level baseball players, but they can't, again, because the mass isn't enough. So there is a perfect spectrum here. So just keep that in mind. That's kind of where we want to work with our loads and where we want our athletes to be in terms of the dynamic effort method. And then obviously, as I've got on the screen here, Louis Simmons of Westside Barbell became acquainted with this idea and this method, from reading the books and talking to the Soviets and figuring this out in the early 80s. And he started incorporating it into his training with his powerlifting team and lifters at Westside. And it's basically been around ever since. Louis obviously used bands and chains and things like that. We'll kind of talk about that here in a minute. But, basically Louis was the one that brought this to the forefront for performance coaches, athletes, and what have you to the United States. But this was around before the United States and Louis Simmons picked it up because Louis is very honest. If you ever got the opportunity to talk to him, that he always credits where he got his stuff from. He did not invent, the dynamic effort method. He took the principles from the dynamic effort method and just applied it to powerlifting. So he's responsible for that. Yes, but the dynamic effort method as a whole, not so much. Just the way that we think about it when it comes to powerlifting. Okay, so this is kind of where today's conversation comes, is how is the dynamic effort method used for training athletes? Okay, so as a former powerlifter, I've used the dynamic effort method. I've loved it. I think it's super underrated for powerlifters, and that could be a completely different podcast topic. But I'm really trying to take this more towards athletes with this specific one because I think it's where the things are muddied a little bit more. I think everybody knows when we're talking about powerlifting, they're talking about box squats and bands and chains and, speed bench, speed deadlift, because those exercises are what the sport competes on. But when we talk about athletes, exercises are a mean to an end. Their goal is to be good at their sport, not necessarily good at speed benching, speed deadlifting, and speed squatting or box squatting or anything like that. So here's where we're talking about how is it used in training athletes. So obviously we're trying to move lighter weights quickly, and that's going to increase the force production. It's kind of what we talked about the past couple slides here. It's all about creating and increasing force production. Athletes generally have to move quickly and create force quickly to excel at their sport. Again, kind of being a dead horse here, but athletes that can perform this task more efficiently, regardless of level, will be more successful physically. But this does not account for skill acquisition, but merely magnifies the skill acquisition. So, we all see those athletes that just have crazy amounts of skill. Think about people like Bo Jackson, playing multiple sports. That's just somebody that has a knack for skill acquisition. They pick up a task, they run with it, they're incredibly good at it, they're incredibly good decision makers, and they make those decisions very quickly. And that's ultimately what sport comes down to, is making decisions, the right decisions at the right time, the quickest, and then you give them, and assuming they have the skill acquisition to throw a baseball or catch a football or whatever it is, then you pair that with the physical side. Somebody's got the high-end physical side. That's what makes you a crazy threat in terms of athletic performance. Michael Jordan had a crazy amount of skill acquisition, really knew how to play the game, knew the X's and O's, made the right mental decisions, and physically he was just above everybody else, literally the way he could jump and perform everybody else at his era. And, he was just very dominant. So the big thing here that we're talking about the dynamic effort method, but also skill acquisition, is that we're trying to improve their tasks efficiency regardless of what level they are. Whether they are a pro level player or a high school player. The goal is to increase their force production, and if this can help us do that, then we set them up for success physically better, and that may make up for some shortcomings on the skill acquisition side until the skill acquisition gets enough practice. Because a lot of times that is just getting quality reps in. The longer somebody's played a sport, generally the better they're going to be because they've got more repetitions, they've had more time to think about that sport and make those mental decisions. They learn from mistakes, they learn from positive reinforcement as well as that negative reinforcement. And being in those positions lets you be a better athlete because you've been there before and done that. And so obviously the longer you play a sport, the easier it is to have those skill acquisitions than if you don't do it. Okay, I think that's kind of obvious. So this should be the number one focus for the majority of athletes, is increasing force production. Max effort and repetition effort work is still important for the balance of the athlete. So we're not going to say we're going to ignore max effort or repetition effort or whether it's important, but we're just saying that dynamic effort should be the number one focus for the majority of athletes, because that's what I want to focus on. This would be the trait that you see is the most important, is creating force, rate of force production, as well as being able to absorb it and change direction and all that kind of stuff. That's what makes them great. Okay, being able to squat 800 pounds is not going to make them a better baseball player. It's just not. There's a return of diminishing effects at some point. And for every athlete and every sport, that's going to be a little bit different. But it's part of our job to realize, do we need that? So it's not saying that we don't think athletes should get stronger. If an athlete can't goblet squat a 40-pound dumbbell, then yeah, we need to get stronger to be able to increase our force production. But assuming that they've got a good general foundation of strength, the dynamic effort method is going to be the most important of being able to create that force. So we only need so much strength, but you can really never have enough force production or rate of force production. All right, so the next thing here we're going to talk about is dynamic effort training frequency. How often should you do it? So the Soviets figured out that with their athletes and humans, even the most athletic athletes that they have, they can only sustain training maximal weights so many times per week before their bodies literally start to degrade, break down. They can't recover. Performance starts to actually go the other way. Right? The goal is for performance to always get better. And if you start to see a decrease in that, then the big question is why? Are we training too much, too long, too heavy, too frequently? All those are all questions that you have to ask. So dynamic effort training in terms of the frequency is something I want to discuss, because I do think it's something you can do more than a lot of max effort based training all the time. So for athletes, this should be done basically every single training session to some degree. Okay, this is definitely my opinion, but because it's easier to recover from, you can do it more frequently. And if you're an athlete, you're probably training anywhere from 1 to maybe 4 times a week. Okay. Very few athletes are actually in the weight room doing performance training more than 4 days a week. Now, if we take football, they might be in the weight room 2, 3, 4 days a week. And then they've got some conditioning days and what have you. But again, you're looking at something like a high-low model, from Charlie Francis, to where those are managed. Again, it kind of falls back to what we're talking about here, is being able to manage that workload, and the dynamic effort method lets us help do that. But you can still probably do it every single session. Just it doesn't always have to be for the same body parts, right? It doesn't have to be the same movement, same plane. You've got some options there. But I do believe it should be done basically every single training session, unless if there's a reason we're trying to purposely pull back and not do it. Ideally, again, I think this is 2 or 3 times per week for most athletes to be in the weight room, focusing on strength conditioning, sports performance-based training. If you're doing that 2 or 3 times a week, doing the dynamic effort method every single time you're in there is not going to be a problem. It should just be able to be done. There's got to be some accumulation to build athletes up to this, right? But I mean, outside of that, once you accumulate them, you should be able to do it basically every training session. Athletes do have sport practice and a competition schedule to manage on their plate as well. So sometimes only once per week may be realistic. And again, going back to training athletes, we've got to remember their ultimate thing here is competing at their sport. And again, I mean, I kind of just brought this here. They obviously are going to have practices several times a week, much more than they're in the weight room. That could be Monday through Friday. That could be some weekends. Depends on seasonality. Could even be some Sundays. Game days on Saturdays for college football that just started up. So I mean, that all makes complete sense, right? So I think that's the big thing to make sure you understand is that you've got to be able to manage around all of those other stressors so that the athlete can not only be ready for competition, but be able to handle practices and then also add the training on top of it to be able to recover from everything from top to bottom. So sometimes 1 day a week, and I know for us, for some of the kids that we get, 1 day a week is super realistic of what we can try to get out of some of these kids. I mean, they're practicing Monday through Friday, they've got games on Saturdays or a couple games in the week plus practices. If we get them in 1 day a week, that's honestly usually enough to keep their performance enhancement that we built. And for some of them, they may even get better over season by being able to stack things together. And so they've had a long, training career with us, even 1 day a week. They're still getting better very, very slowly over the course of the season. So by the time sectionals, regionals, whatever comes around, they're actually feeling their best. And that's ultimately our goal, right? Is to be able to excel at the highest level that we can get them at, so that they can do their job for their team or for their individual event. But remember that speed and power residuals are also 5 days plus or minus 3. Okay, so generally speaking, when we're training speed and power as a trait, that trait's going to last for 5 days plus or minus 3. So this is important because, again, if we can get twice a weekend, we're not going to have to worry about there being any overlap, right? I mean, you spread those days out to Monday, Wednesday, Monday, Thursday, Tuesday, Friday. That residual, you're always tapping that trait, always tapping it. And you're never going to see it decrease. You're actually probably going to see it increase, which is our goal. If you're coming 1 day a week, could see a little bit of a drop off, maybe. That plus or minus 3 days could happen quite a bit. But chances are you're probably going to be okay, especially if you got a lower training age. As when you have a higher training age, that's going to matter more. But if you got a higher training age, you probably have the ability to get into the strength conditioning room a little more frequently, or you're working with a performance staff, something like that, to where you're probably still going to be in the weight room 2 days a week, regardless. So you're probably going to be okay. But again, remember that the residual is the smallest one that we have in terms of training. And I think once you figure that out, then you're going to be good here. So the next thing is the execution of the dynamic effort training that we're going to be doing. So I think, again, this is for athletes. So I think many people think this has to be barbell-based work to be effective, but this is far from the truth. Jumps, loaded jumps, various plyometrics, med ball throws, slams, spring variations all yield dynamic effort method responses, and develop speed and power. So you can get your effort, your dynamic effort method from these things. You don't have to speed squat, bench press, and deadlift. Now, the key here is where you're at on that force velocity curve, which we'll have a slide up here in a minute. We'll talk about that here in just a second. But the big thing to remember here is that as we do those, we want the loads and things to be in the right area. So you got a super, super springy athlete and they're doing a lot of jumps. They're probably not in that dynamic effort profile that we want. They're probably on a faster end of that spectrum, which we'll have on the curve here in a second. But you could load it with dumbbells, kettlebells, trap bar, and get that to get a dynamic effort response without actually having to, again, deadlift or squat. And same thing with your plyometrics. You can do band resisted variations to slow things down or speed things up. Your throws, your slams, those are all can be done. Just, again, find the right loads. And then same thing with your sprinting. Usually that's more your higher velocities. But again, if you want to do sled resisted sprints or push the prowler, you could get it into that range. And then you're going to be good and still be training the dynamic effort method. So you can touch this. And to me, dynamic effort method, it's going to talk about like the velocities here in a second. But to me, if you're doing something fast to create speed, you're basically doing dynamic effort training in terms of that. So hopefully that helps. Now, the goal is that, again, it must be fast, but also allow us to ideally generate maximum force. So, if you're not generating maximum force, then we're missing the boat here. So again, I kind of talked about speed. Usually when you're running, you're going to be able to create maximum force because your body's able to continue to move through space, right? You're still having to fight gravity to some extent, but you're literally ripping yourself through the ground to propel yourself forward, to be able to make progress. And then your mass is the same because that's always your body weight. So keep that in mind. It's not just barbell work. You can sprint, throw, jump, and it's all going to check those boxes. And again, another reason why, from a training frequency perspective, you can do this literally every single day when you train in the facility. So for barbell based work, though, ideally you'll see 40 to 80% of 1RM loads used with or without accommodating resistance. And again, accommodating resistance is bands or chains, I should say. You could technically combine them together if you really wanted to. And that accommodating resistance weight needs to be around 15 to 25% of the barbell load that you're going to use. So if we're talking about the squat, we're talking about the bench press, talking about the deadlift, that accommodating resistance at the top needs to be in that 15 to 25% range, because if you add that to those percentages that we talked about here, the 40 to 80, if you add those to those, then you're going to see we fall in that good spectrum. Now, the 80% is so high because it's assuming that you don't use any accommodating resistance. So my suggestion would be, once you get past about like 60, 65, percent, that's probably the upper range that I would be in if I were you. If you start going into 70%, I would probably stop using accommodating resistance at that point, or very, very little, like maybe 10% or less, just so that the barbell can actually slow down at the top. But generally, you're doing compensatory acceleration training, which is essentially the same thing. It's almost just, I don't want to say it is the same thing, but the goal is to be applying as much force on the barbell all the time, regardless whether you have bands or chains on it. But that is true compensatory acceleration training when there's no accommodating resistance on the barbell. So 70 to 80%, I would say don't use bands or chains, just use the load. If you're going to use bands and chains, then you need to be in that like 40 to 65% range, and then pick your percentage of your accommodating resistance that fits nicely with your athlete profile. That can be heavier, that can be light. We can talk about that here in just a little bit. So for speed recommendations, I've got a nice little velocity zone chart here for this. But for athletes, we know that we need triple extension to be the most successful for our athletes, right? So the thing that makes them incredibly successful when it comes to running and jumping is there's triple extension. So extension of the hip, the knee, and the ankle. Missing that, you no longer have triple extension, which is okay. But with powerlifting, we don't have triple extension. The feet are flat. The ankles never go through, extension. So we're only focused on the knee and the hip. Athletes, we've got to have that triple extension, which again, why I really like loaded jumps and different sprints and different med ball throws with broad jumps and things like that. Like I think that does a good job of seeing the transfer over to the field, court, and pitch, more so than just doing speed squats. But I do think the speed squats obviously have a high importance. You want violent hip extension to be able to hit people to run fast, to jump higher. So when you're programming barbell movements, again, particularly squat and deadlift, we talked about they were missing that. And again, it's where the jumps and the sprints really shine for force output. And on this velocity zone chart here, you can see that we've got different adaptations that come based upon the percentage of 1RM, assuming we used a barbell-based load. So we've got a couple different options here. Obviously, if there's nothing on there, that's going to be your highest velocity, right? Outside of using an assisted training measure. So think like a band assisted jump or a band assisted broad jump. Those are going to make you move faster than what you can normally do, because you're going to jump farther or jump higher. That's going to be basically more overspeed type training, which again has its value. It's incredibly important. It's good for peaking. But usually when you're in that 0 to 20% range, that's considered starting strength that you're kind of training. And that's going to be greater than 1.3 meters per second. Okay, so that's really, really fast. This is talking about doing sprints with your body weight jumps, things like that. Then, you're seeing some benefit there. Then we've got the next part here. We got speed strength. That's going to be 1.3 to about 1.0 meters per second. That's about your 30 up to about your 50, I'm sorry, 20% up to about your 40% range, give or take. It's maybe 45. It's really going to be fast, but you're going to need some load to slow it down just a little bit. So, think of this as like maybe some really, really light weighted jumps or some like band resisted sprints that you're starting, but it's very, very light band tension. You've got a super light weight on the barbell and you're jumping with it. That would all fit this very nicely. And then, we've got kind of our middle ground here where we got our speed strength, and that's our one to, you kind of see conflicting numbers here, but 0.75 meters per second or 0.8 meters per second, but that's your strength speed. That's our classic dynamic effort training. It's got you, again, we talked about the percentages here on the screen. It's basically got that 45 to 65 range, 70, that's perfect, right? We know what that's going to be. So we have ability to measure your speed here. That's awesome. And then the last part that we've got here is the heavier side of training. So this is where we're still going to start to see some force, but we're obviously going to have the mass increase so much that the acceleration is really going to start to fall off. And that's going to be your accelerative strength. Some people I like to call this like basically your max force. Based on force plates, it seems that the 0.5 to 0.6 range is going to be where you can get the highest force actually put into the ground. That could be, variable depending upon the athletes that you're talking about. But if you look back at the literature with compensatory acceleration training, you're probably going to see that that's where those numbers fall, that 70 to 80% range, no accommodating resistance. That's kind of what you do, right? So that makes sense with the literature, that why we would see that being power. That's what in normal classic NSCA textbooks, that's what you're going to see as power training. And then anything over that is considered absolute strength. You're basically after trying to get stronger, which I think, again, has it's important. You got to be so strong to be able to create so much force, but understand that no longer is the barbell moving fast. It's all about how much weight can we get on the barbell to be successful. So understand where you're at in this ranges. But again, for dynamic effort training for athletes, we're really trying to stay on the further side. We're kind of in the middle, but shifted to the left if you're able to see where this able to see the images. So hopefully that kind of helps you there. All right, now we're going to talk about the force velocity curve. And again, why this is important. We're going to take some of those numbers that we just talked about and basically put them on this curve. So if you're looking, if you're looking at a curve or you don't know what the force velocity curve is, go back to your, high school, 9th, 8th, 10th, whatever math class, where you've got your y-axis and your x-axis, where your y-axis is your force, your x-axis is your velocity. And basically you're just going to make a nice curve going from the force being really high, where the velocity is slow, and you're just going to draw that down. And then that's going to be your force velocity curve. And depending upon the percentage of the weight that you're lifting, you're always going to fall somewhere on this velocity curve. And so the dynamic effort method is usually right here in the middle. This one, it basically calls it peak power. And it's got strength speed at 89%. They kind of use some interchangeable terms. But really the goal here, as you can kind of tell, that 30 to 80% range for most athletes is where we want to be in terms of being able to generate as much force and doing dynamic effort method training. All right, we don't want to touch those really high numbers. We don't want to touch those really low numbers. We want to be somewhere right there in the middle. But understand that you do have to hit the faster spectrum. So that's going to be your sprints, your throws, your jumps. You still want to hit that. And then you can still hit your dynamic effort method, power, whatever you want to really call that there. And then obviously you still want to be able to touch your maximum strength qualities as well. And then what that does is that shifts the whole curve up and to the right. That's the whole goal. We want to increase the amount of space underneath that curve. And so the more area that's underneath that curve, the better the athlete is going to be. They're going to be able to create more force. They're going to be stronger. They're going to be faster. And that's going to set them up for more success in the long run when it comes to their performance on the field. Then we need to remember the ultimate goal. So while the dynamic effort method is popular in the powerlifting world, the goal with athletes is to improve on-field court pitch, swimming pool performance. More power, more speed, more movement variability will ultimately equal a better athlete on game day. So you've probably heard this analogy a million times. There is no squat rack on the football field or on the track, and that's absolutely 100% correct. So we got to remember that this is a means to an end. We just got to make sure that it's one, sustainable, two, they can recover from everything, and then three, that it's helping that athlete for their particular sport. So power is plane specific. How you develop it does matter to the plane that you create it. So if you want to jump higher and you're always jumping side to side, you at a very young age, you might see there be some transfer, but as the athlete ages and becomes more advanced, that's no longer going to help them jump higher. To jump higher, we've got to train vertically. We got to apply force into the ground, push ourselves up, jump as high as we can. That's where squats would be great. That's where hex bar deadlifts would be great. If you're talking about you're wanting to be able to push somebody out of the way, again, you got to have upper body power pushing horizontally. Only doing vertical pressing will not aid the horizontal pressing. So keep your power plane specific. Look at the needs analysis of your athletes, and that's ultimately going to help you pick your exercise choices. And then everything else kind of falls into place. You've got your speed that we kind of talked about, where the velocity ranges need to be, how fast it needs to move, kind of percentages if you're using bar weights, and that can help you, again, dictate where you need to be. So again, we can still use this quality information, training methods from powerlifters. So again, I still think obviously doing all this stuff is incredibly important. What Louis has passed on is awesome. We definitely want that. But weightlifters also, again, when we talk about the snatch, clean and jerk, also providing us great information on that as well. But we want to use all that to help build and enhance performance, not go into a rabbit hole of working on a perfect squat or a perfect clean. But we understand that may look different, and that's entirely okay. So that's just the big thing there to remember. Now, I will say that, if I go back here really quick, you'll see that I've got some velocities on here. With the speeds, we use a rep 1 unit. It's pretty cost effective. It's like $300 or $400, something like that. And it's a linear transducer. So it's got it's basically a Tendo unit, but a really small unit. I think that works great if you do want to measure these. And we have been using it more with our high school kids to make sure that we're in these qualities. So if I'm wanting to make sure that they're in the absolute strength, they no longer get to really pick their loads anymore. The unit will help me dictate whether it's heavy enough or not. So usually if we're doing absolute strength, for example, I'm giving them a 0.3 to 0.5. 0.5 is the fastest that it can move. 0.3 is the slowest it can move. As long as your reps are in there, then we're good. And, over the course of the month, we can kind of phase it. We can start closer to that 0.5. And over the course of the month, I want to get closer to that 0.3. I really want to load it up. The athlete thinks, man, it feels heavy. But the thing is, the velocity of the barbell tells me that we can do more. Your body is capable of more. And it's nice if you've got athletes that, I don't want to say sandbag it, but it feels heavy, so they quit working, even though you can definitely get more performance benefit from it. Same thing with the speed aspect, the dynamic effort we're talking about. I really like using this with the bands and the chains with our athletes. If we're doing some kind of dynamic effort based training, that I can control the load based on the velocity of the barbell. And there's other units out there, but just understand that, if you were looking for a way to actually track this, then I think that's what I would do if I were you. And I think you'll be in a good spot there. And so programming, I wanted to discuss this as well. We've got, this is what I personally like for a given week of training. Okay, this can go up, this can go down, but generally speaking, this is kind of what we're looking at with our high school athletes and some of our middle school athletes. Depends again what time of year and all that kind of stuff. But generally, every week we're trying to do this. We're trying to get 25 to 50 ground contacts of vertical jumps. We're trying to get 25 to 50 ground contacts of horizontal jumps. We're trying to get 25 to 50 ground contacts of lateral jumps, so moving side to side. We're sprinting. We're trying to get to 12 hard efforts per week. But again, this is highly variable depending on distance. So I just try to track this in terms of efforts more so than anything else. because then you can say, okay, well, we're doing 3 25-yard sprints. That's probably going to be good. Okay. If they're really good efforts, they're probably going to be good. But if you're doing 3 10-yard sprints, probably not enough volume, right? I mean, that's only 30 yards of running. The one person running the 25 yards almost ran as much. So again, you got to kind of look at what you're getting here from your running perspective. But the 12 efforts is a good example. Doing 12 hard 10-yard runs, basically, so you're doing 2 days a week, 6 hard runs each time. That's probably going to be good. Okay, as long as they're putting in that effort. And then for your throws, your upper plyos, 25 to 30 reps for the week is usually a good spot. And then I think I've got another one here. Yep. And then we got another page here. So speed squats for athletes, 4 to 6 sets of 2 to 5 reps. And I also have on here that we use split squat variations for our speed squats. So that is another really big caveat here, is that many athletes are playing on one foot or one leg at a time. You're running, you're usually in the air, one leg's going to land, and then with the gait cycle, the other leg's going to land. So being strong and being fast on 2 legs is awesome, especially if you're talking about basketball, volleyball, you're jumping off 2 legs. But you got to remember, a lot of sports are also playing on one leg majority of the time when you factor in their running, right? So being able to train that in a unilateral based method or idea is just as important. So we do like to do this with split squat variations with like the safety bar or a front rack position to develop that speed quality that we're after. And again, 4 to 6 sets for most athletes is good, because again, if we're doing all of our jumping and stuff, we're doing some of this, and if there's a second day, we're getting 8 to 12 sets. If you add that 4 to 6 sets up, we're getting 8 to 12 sets of 2 to 5 reps, which is what Louis and the Soviets were basically doing with their sets and reps. So just keep that in mind. That's kind of where those numbers came from. And then speed deadlifts. Here we got 4 to 8 sets of 1 to 3 reps. And again, just like we talked about the speed squats or the split squats, we also use kickstand options or B stance, whatever you want to call them, to actually get some unilateral hinging for speed as well. So, don't think that you just got a trap bar deadlift or conventional or sumo. You can definitely use a kickstand variation as well. And then also the weightlifting variations, so snatch and clean and jerk. Usually we do 12 to 20 total reps in a given session. And it depends on the variation, that you're using and how new the athlete is the movement. That's usually the hardest part, is getting athletes to get skill acquisition of the movement. That's one that I knock on weightlifting, is that it's so skillfully demanding that by the time you actually get the demanding part done, you could have just jumped and gotten all the performance benefit. I do think there's some merit to that, but I also do like to use the weightlifting variations to teach them that triple extension. And it is hard to teach them, but it's not impossible. You can see benefits from it. We've got several athletes that have done fantastic with it. So as a semi-private facility, I get to kind of pick and choose who I want to do that. So if you're working with a team, I understand it's a little more difficult. So we just give it to the athletes that we think that are both mentally and physically ready for it and are quick learners. And they usually do fine with it. So, I'm not giving it to every single kid. I'm being a little picky. But again, this kind of gives you, from a programming perspective, how we kind of look at it. And again, counting the total reps in a given session, because we do like to use a variety of things to teach them. So we do like to use, like hang clean high pulls to a hang clean with a front squat, teach them to go down and get the weight, teach them to get the triple extension. But we still get a lot of benefits from that. So, it really just depends on what kind of complex you're using. If you are using a complex, or if you're just doing a hang, or if you're just doing it from the block, so a floor, that all kind of comes into play. But usually if you're in that 12 to 20 total reps for the whole session, that's your working load, I think you'll find that you're going to be in a good spot depending upon what you got going on. But you're probably not going to do too much, but you're also not going to do too low. And that leaves me open for the discussion part, to where literally, we can talk about this all day, but I do think that when we're looking at the dynamic effort method for athletes, I think I covered a lot of the major stuff. So hopefully that helps you. And it does look like Brandon Nelson joined in. What's up, man? He said, what if you see an athlete 2 times a week? Do you combine planes of motion for jumps and throws? So I'll put that on the screen so you can see it if you're watching. So we see a lot of our athletes 2 times a week. And so usually we try to look at things set up linearly and vertically. So we like to put our sprints and our vertical jumps together. So linear speed and acceleration, and our vertical jumps. So box jumps, hurdle jumps, weighted jumps. Those all are usually together on that day, and that's usually the day that we squat. So it'll be whether it be a safety bar or a split squat, or whatever that squatting variation is that we've chosen. That's what we usually go for that day, and then we'll make sure that we've got a lateral lunge or something like that in that day. So we're still moving side to side, but that's not our focus, but we're still checking all those boxes. And then on the second day, that's where we do usually our broad jumps, and then we do some kind of horizontal jumping. And then that can be lateral hurl hops, lateral bounds, anything like that. And then usually if we're doing any kind of sprinting or throwing, that's where that goes. So if they're a baseball, that's where the rotational throw is going to be. If they are not doing any kind of upper body stuff like that, then they're actually going to do lateral runs or change of direction based work. Think about like basketball, for example. That's where they would do all their hip turns and things like that to move side to side. That's usually where they deadlift. And then usually we do some kind of other single leg variation later on in the training day. And that kind of helps us check all the boxes on both days. We're moving side to side both days. We're moving up and down both days. And we can even do upper body power on whatever days that we think is the most important. Obviously most sports are still doing some kind of upper body power, but it just depends on what the sport is. So that's kind of how we do it with 2 day a week athletes. I think it's worked out really well that we just got to check a lot of boxes, and they get that skill acquisition of moving side to side 2 days versus just one. I've seen it work both ways too, where some people literally just have a lateral day and that's all they do is run sideways, move sideways, lateral lunge sideways, and then do all their vertical stuff on the other day. I got a younger population, so I think the more I can get them to move sideways throughout a week, the better off they are. But that's just what's worked well for us. So that was an awesome question. Thanks, man. I appreciate it. And it looks like for today, that's all I've got on the lecture side of things. So I hope you enjoyed that. This will be up on YouTube. So if you want to go back and look at it, you are definitely more than welcome to do so. We should have this also on Spotify and iTunes, as I mentioned. So that's all I've got for today. It looks like it's been about 47 minutes or so. That's really good. I think that was a good amount of information for you. But at the same time, we're also going to again have this on October 1st, 1 p.m. Eastern Daylight Time. That's when the next one will be. I've not determined a topic yet, but I've got several weeks to do that. I will have that over on Instagram. So again, give me a follow on Instagram if you want to keep up with that stuff. Again, on Spotify, iTunes, Stitcher, YouTube, all that. That's where else is going to be. This again will be on all those places. If you happen to listen in hindsight, you want to look at the slides presentation, that will all be on YouTube, and you can just go watch it there instead of listen to it if you want all the visual pieces. So again, if you came on, thanks. I really appreciate it. If you're watching this in hindsight, I hope you took something. If you got questions, just let me know in the comment section. I will answer them as soon as I possibly can whenever I see them. And if you're listening on a podcast, just feel free to reach out to me personally and ask a question if you have one. So thanks again. Have a good Sunday. More football, a lot of college football this week. Purdue lost, which sucks, but it is what it is. We'll see what happens next week against Virginia Tech. But again, have a good weekend. It's also Labor Day too, so have a good Labor Day weekend. So if you got Monday off, awesome. Enjoy that day as well. And we will see you live next month. Thanks. Have a good day.